And then he has been a postdoctoral researcher at Hospital Clinic in Barcelona, so getting then very close then to the medical doctors. And through the research project, he has collaborated also with the World Health Organization, applying interpretable machine learning for prenatal risk assessments in African communities. And so now he's basically then also embracing entrepreneurship. And this is why Sergio is his. And then transferring then technology, focus on the development of innovative computational solutions to support the diagnosis of disease through ultrasound imaging. So also then continuity of his main research expertise then developed during the PhD and then hospital clinic time. Then we have so Morteza and Pablo here in the middle, working on the same project with bit different backgrounds. So Morteza holds a bachelor degree in aerospace engineering from the Malek Ashtar University of Technology in Iran. I hope I'm pronouncing it correctly, more or less. And he has a master in aerospatial engineering from Sharif University in Technology. So he defended his PhD thesis at the end of 2023, as it was focused on the in silico personalized modeling of instrumented thoracolumbar spine models. Some of you are doing actually the hands-on with him, so you're well familiar with the technology. He has received different recognition then for his work, and now he's working basically as leading the technological developments for the transfer of this technology to clinics. So based on very encouraging results that he gained with technology. Pablo is a biomedical engineer, also trained here in the biomedical engineering bachelor at UPF. And so he has then decided then to follow the path of entrepreneurship. So he's basically then, he has been involved in Barcelona Activa, in ShareTech training, also online Harvard-based training. So during more than 1 year in entrepreneurship. And so he has then decided to team up with Morteza in order then to promote the technology transfer of the technologies that they will present, but then focusing on the business development. So that's it. You know who is who. Now I will then give the word then to the different speakers. So let's start with Sergio.
Thank you, Jerome. I'm Sergio, and I'm going to present this project, TransCore. And TransCore is actually technology that's been developed through different research projects. And it's actually in 2023, so only last year, that we started to see whether this technology or if there is any part of the technology that has potential to be transferred to the market. And what is TransCore? I will be explaining it throughout the presentation, but it's basically a software platform to support clinical decision-making in cardiology. So the talk is going to be mainly a pitch that we were doing last year for different calls, and then the story of failure or learning, because we were kind of failing in a couple of grants and subventions that we are asking for, and now how we are kind of changing or reorienting the product according also to this customer discovery, to having interviews with customers, and how we are pivoting the entire project and the idea behind it. So that was the pitch that we were doing last year to ask for different projects. And as I said, TransCore is a software platform that allows managing and analyzing ultrasound images to guide or to orient the clinical decision-making in cardiology. And why cardiology? Well, cardiovascular diseases in Spain are a major cause of mortality and morbidity, and actually, so the trends with the increasing age of the population, these numbers are growing. This is not working, is it? Now, with this aging of the population and the more and more mortality and morbidity associated to these diseases, and also together with all the diagnostic tests which are available nowadays, mainly imaging, lab tests, all the electronic health records, this supposes that the clinician at the end of the day needs to interpret a huge amount of data to then try to diagnose diseases over these patients. And this is mainly a cause of burnout in the healthcare personnel, which leads to a huge amount of diagnostic errors, which could be prevented. And these errors cause that at the end, the decision that the clinician takes goes for a delayed or an incorrect treatment, that it actually can cause harm to the patient, or actually also at an increased healthcare cost. If we are wasting money in treatments that do not work, then this is obviously very bad for the healthcare system. So in this context, we said, okay, let's use the technology of TransCore, which is a web-based and vendor-neutral software platform. And what is this vendor-neutral? Meaning that, in a way, we are able, with our platform, to analyze images from different vendors, being like Toshiba, GE, Philips, and so on, to then design. These tools are designed to collect and analyze ultrasound imaging through AI to, in the end, support the clinical decision-making in cardiology. So meaning finding the right patient, giving the right patient the right treatment at the time that it most needed. And now in this pitch, what we were doing, you normally need to demonstrate that you are already, or that you already have something, no? So what we were saying is, what we have is actually we have a prototype available, which is deployed on Amazon, but it's also deployed in a couple of hospitals in Sant Joan de Déu and also in Hospital Clinic. And the AI that comes with it, that I was playing, it's validated, and the models are trained over more than 5,500 ultrasound studies, and this was leading to different publications. Now, before starting explaining more or less the detailed solution, I want to guide you through where we think that with AI we can impact this clinical decision-making journey. And it's mainly starting in data collection. So through AI, you can actually help clinicians to enhance the quality of these images. So for example, guiding while you are doing the ultrasound, there are already softwares that allows you to take the most standardized or the best plane for the heart. Now, AI can also help in the feature extraction step. So once you have high quality data, then AI can help you extract different features, being these features anatomical features or functional features of the heart. Now you have this, you then go to the interpretation step, where you actually look at an aggregated or different sources of data to then decide whether the patient is healthy or diseased. So you are actually interpreting the state of the patient, and with that state, you can then go towards supporting the decision. So if you know what is the patient, the phenogroup to which it belongs, and then you have information on what was the treatment outcome, then you can actually guide this decision to say this treatment yes or no, or watch and see, or make a follow-up on this patient. So in the data collection part, what TransCore is currently doing is actually we have this platform where clinicians, in a collaborative way, they enter different studies, they do open this kind of feedback forms, and they provide feedback on the image. So whether this image is good or bad, and they are assessing different criteria on this image. So now this data is useful for two purposes. One, we were using this in a project in collaboration with a low and middle income country, which they are lacking the resources both of healthcare personnel and technology and training programs for the people at field acquiring images. So this solution was helpful as a training tool for the people at the field, obtaining the feedback from more senior clinicians, telling them this image is good or is not good. And throughout time, we saw that actually with this intervention of using TransCore, the learning rate, the learning curve of these clinicians augmented, and the acceptance of the images for subsequent diagnosis improved. But not only that, also this quality control step helps us having ground truth information to then train models that actually when they see images, they can already tell or give feedback on whether the image is good or bad for this subsequent diagnosis. Now, once we cover the first part, we go to the feature extraction piece. And now TransCore, or what we did, and throughout our platform, we have many tools and utilities that allow clinicians to actually see the image and do segmentations, which are manually or semi-automated, both in the heart, but also, I mean, we've worked in projects with fetal imaging and different modalities like B mode, Doppler imaging, M mode, etc. And throughout this collaborative project, research projects, we also obtained a lot of ground truth information to then train deep learning models to automate the entire process in the way that when a study is uploaded to the platform, there is a process in the background that it's already extracting all these features and presenting kind of a summarized report to the clinician on what are the different clinical parameters of interest to then pursue the next steps for diagnosis. And our claim here in this pitch was, okay, we have this technology that is valid for this, data collection also extracts features, and this feature extraction and report generation, it's actually, or it could be very useful because comparing with the standard of care, having such solution allows you to generate a report in less time, so you can make more echoes per day, and then you are generating value for, in this case, for the hospital. And then in this pitch, so we had to do a business model, what is the market, and the impact that you will do to society. And what we were like thinking, and again, this was last year when we started doing these kind of pitches, we say, okay, TransCore will be offered in a B2B model, so directly to the to another business and not to the client. And we thought, okay, probably this software could be interesting for pharma companies, for medical device companies as well, and also to software, that they will be interested probably in acquiring part of the technology or of the software, but also the large amount of high-quality annotated databases that could be, I mean, in a way, interesting for these companies to train their own models. And about the impact, so we started to say, okay, if we focus on heart failure, which is one of the most prevalent cardiac diseases that affects up to 3% of the adult population, and it has a huge cost for society. With this such platform, we could kind of automate this process and then impact to lower the disabilities and mortality, and in a way also improving the quality of life of these patients. And also in the least developed countries where they are lacking resources, both of personnel, but also equipment and so on, we could use our technology to kind of democratize the access to this quality care. And that was the plan, the roadmap that we had. So starting last year, we were gonna ask for different grants, mainly so public money, to then start delivering this MVP, starting protecting the technology, getting the customer feedback, and then starting develop the business and so on. But the story is that actually this is the case where we are at now, where we got money from different networks supporting tech transfer. Also, we got money internally from the TIC department in this Maria de Maeztu Excellence Program. But when we were concurring to Producta, Innovadors, Kaizen Pulse, so these grants which are giving you money to transfer your technology, we didn't succeed. And this is now kind of the reflection of what we are doing now. why the format we were putting this didn't succeed. Now, the first thing that we did after failing these different grants, what we did was, with the support of the Sharjah for AI and with external consultants, we started to really put our ideas into this business model canvas, where you actually say what is your value proposition, to which clients are you solving this kind of need, what is the commercial relationship, and through which channel are you going to market your product, what are the key activities and key resources for this product to be a reality, and then what do you actually need in terms of what is the cost structure, and then the most important, the revenue that you will get. And through this exercise, we were identifying that at the end of the day, we needed to talk more to clinicians, but also to people from industry to see what they think about our technology. So what we first did is, in this customer discovery stage, we were starting the last couple of months talking to clinicians throughout this kind of consulting phase, where you actually make an scripted interview, where you try to understand what is their problem, then you present your product and how your product could answer the needs of your potential client, and then you really validate or iterate, or you detect where your product falls short. And what we actually found is that this feature extraction piece that we were saying is actually partially solved by big players, and if not solved, if this is not completely automated as of today by GE and Philips and Toshiba and so on, it will come in the next couple of years. And one thing that they say is that in pediatric cardiology, this feature extraction piece is probably still lagging behind, but obviously you always need to consider what is the market. And at the end of the day, the pediatric cardiology market is actually limited. Now, also, there was consensus regarding the importance of, rather than sticking here, going further on this decision-making process, which actually making a diagnosis or going towards decision support implies that your product as a medical device will be classified as a higher class, like 2B, 2C, and then this will require more regulatory process in order to clear a product. Now, with this kind of exercise and talking to clients, we were going back to what we thought were the competitive advantages of our product. And what we found is that actually we were being very optimistic, because we were saying, oh, TransCore is web-based, or is accessible through everywhere, it's vendor neutral, it does quality control and automatically assesses the quality of the images. It also enables AI automated measurements and stuff. And then we say, okay, let's compare to the big players. And naively, we were saying, okay, we are the best, and these guys are having many things that are missing as compared to us. The reality is that actually the big players, I mean, they are obviously, if not integrated already, they have everything already in their pipeline to have all this automation and give you already a summary report with which to make a diagnosis. And not only that, but they have like the power, the personal power, the money. They have contacts with the hospitals, so they have like big networks of market access where they can go everywhere. And also the technology that they use in the end, the AI that we are going to use at the end of the day, it's just these huge models, and what it really matters is the data that you have. And as compared to like smaller businesses, to like startup companies, we were also being very optimistic as compared to this. And the reality is that these startup companies are already going, because here there is no more market, they are going to more the interpretation or the decision support part. And actually, when looking at, for example, these two, Ultromics, US2AI, they are already automating this part, but they are going to already start diagnosing heart failure or other conditions. And the thing here, or what we found that is key, is that these companies have contracts with major corporations. For example, Ultromics, they work with Mayo Clinic, they work with Stanford, they work with KCL in London, and they are supported by St. Guy's and Thomas Hospital, so they have huge amount of large collections of data. And US2AI, these guys are in Singapore, and they have access to most of the clinical trials in Asia. So this is like huge amount of data, and they are also in contact with people in Boston that also centralize clinical trials in the US. So these guys, they just have enormous amount of data, so it's difficult to compete there. Now, in this customer discovery phase, we did not only talk to clinicians, but also to people from industry. And what we found is that actually, even major corporations, like for example, I was talking to a guy working in Bayer, and he's developing AI to automate the analysis of tissue imaging, so like whole slide images of tissue to detect cancer. And he was saying that even though they have data lakes with huge amounts of data, still in these large corporations, they always have fights between departments of who is the owner of which data, who has access to what, and it's always a mess to access this data. So pharma companies are actually spending millions of euros in doing clinical trials in a centralized way, where they actually have the data into a central repository, they analyze it, and they use these results to then improve, for example, their drugs. So taking this into account, we make a step behind of what we thought that we had with TransCore. And actually, there is a part of TransCore which is all these management functionalities, because actually TransCore, the way it is deployed now in the cloud and in different hospitals, allows for teams to work collaboratively and access data which is in hospital clinic and then in the cloud. And then we also have a project in Pakistan where we have data. So it's actually, we had to put in place, and we are actually in the way of putting in place all these security measurements for these data settings. So creating audit trails of everything we do with the platform, of course, working in the data encryption, anonymization of data before being shared, and working like really thoroughly with the informed consent management of the patients and so on. So we say, okay, let's now make a more really objective market analysis and not the optimistic comparison that we did before. And what we did was let's break down our TransCore solution into all the features that has in every of these steps. Let's break it down, and also with these management functionalities. And what we did was, okay, let's look at all competitors. Let's look at how they do with regard to all these features. And then using these features, let's make a principal component analysis to start understanding where are different competitors located. And in a way, we were interpreting these kind of groups, clusters of other companies with products which could be potentially similar to us. And what we found is that there is actually a lack of solutions which are actually dealing with these management features that are needed to establish these kind of multi-center studies collaboratively, and something which is very important in a federated way, meaning federated that you have an infrastructure where the models are going to where the data is, and the models are updated and shared to a central repository, but the data never leaves the hospital in this way. And now this is where we are at the moment. Before we were like selling, we are in a TRL of 3 to 4. But now we are pivoting and going back and then rethinking, because I think for success, you need to pivot quickly. If you are failing, you need to know why are you failing, and then probably go a step behind and say, okay, do we have something that could be potentially interesting? And then what we are thinking now is our technology, all the infrastructure that we are providing, that could enable this kind of modern federated approach to clinical trials, which is actually something which is starting to be explored by other companies like this Bebel Cloud, where they are already deploying infrastructure for decentralized architecture in AI in medicine. And so what we are doing now is that considering data subjects, the entities processing the data of the subjects, and all that, and having into account all the regulations that are governing the privacy aspects of the patient data. We are coming up with a list of requirements that we should comply with all our technology. This is probably a bit too technical, and I don't think I have time. But at the end of the day, the message here is that we are going a step behind, trying to rethink, propose what is going to be our solution, our competitive advantage, how we can design this technology, so we will be in TRL2 in this case, and now how we can implement this to make really an impact and have success in the different calls we are asking money for. And so to start all this part, implementing all this technology, we need money. We were working with VIDAA, they made for us a funding roadmap of the different calls we could apply, AI, health-related, and stuff like this. And for now, we've already applied with this kind of tweak to our project to a couple of grants. Let's hope we are successful, and then we can continue our roadmap in this tech transfer journey. And just this is the team: myself, Bart Binance, whom you know, Josa is a software developer, Carla is working with us, doing also focusing on the data science aspects of the project, and Nuria is also collaborating, helping us with these different calls and to raise money. And that's it. I hope it was useful for you knowing about our this year and a half of experience in this tech transfer path, and I'm happy to answer questions later.
Yeah, we can.
We continue?
Yeah, we continue directly then to the next. Yeah, so maybe, yeah, Pablo and Morteza, you continue because Jordi has to plug his computer.
And you have this?
No, that's okay.
Okay, you use that one.
Well, so I continue for presenting Simo Spine. My name is Morteza, and I'm presenting the software that we call it Simo Spine, and it's for spine surgery planification and prognosis. The thing is that I present 10 minutes for the technology part, and Pablo will continue for the technology transfer part. And the Simo Spine is already in the process of protecting the results by IPR. And I just highlight some technology parts, and I am sorry to tell you that I just put some general items in technology, but I couldn't share with you the whole pipeline of the technology. And for the presentation, actually I prepared the presentation in the way of actually the story, like this. So this is me. I came from Iran, and I was actually aerospace engineer in Iran. I was working with structural designing of aircrafts, helicopters, and all these stuffs. And in general, I was like a mechanical engineer in Iran. And then after a while, I had a morphing process, like metamorphosis from a butterfly to being like a worm shape, but actually like a spine, indeed. So I did the process in morphing process for being from Iran to be here to Spain, to continue working on PhD, working on spine biomechanics and doing my PhD here. And finally, I worked in a group, and you can see here still we have some morphing process in the image. And I work in BCM MedTech group, and I did my PhD, and I defended my PhD recently in October 2023. So integrating aerospace engineering and the spine biomechanics, we have decided to boost a spin-off that we call it Simo Spine, and using some wings and missiles just to boost this spin-off. But for the Simo Spine, actually, Simo Spine is a spin-off, but it's not a company yet. And we don't have yet any shareholders, and we are just looking for some public funds already. And we, in the next step, maybe Pablo will explain later that we will go for like private funding and also investing in Simo Spine. But for the technology part, how it started. So Simo Spine idea was started from Alex Delarco, one orthopedic surgeon in Hospital Del Mar in 2015. And Alex Delarco had the idea for, actually Alex Delarco was an orthopedic surgeon, and he had some idea for improving and planification of spine surgery and like getting better the spine surgery using some techniques like in silico techniques. And Alex Delarco had came to UPF and talked to Jerome to have some idea for using in silico techniques to get better the spine surgeries. And the idea of Alex Delarco was initiated from one mechanical complication, proximal junction failure. And he thought that maybe using modeling and simulation, we can improve the outcome of spine surgeries. So regarding the proximal junction failure, as you can see, the patients will face some mechanical failure after a while, after like 6 months after the surgery. The proximal junction failure can be defined as vertebral fracture, a screw pull-out, and or maybe a screw loosening. But the aim was how can we predict the surgical situation, and also how can we predict the mechanical complication before the surgery, and also how can we planify the spine surgeries. Regarding the mechanical complication, 45% of spine surgery needs revision surgery, and out of this 45, 25% will have mechanical failure. And if the patient have a mechanical failure, they need to be reoperated. And also the planning and prognosis of spine surgery needs to be improved. And as I mentioned, the proximal junction failure as the initial point of Simo Spine, we have defined it that the PGF cases needs to be reoperated. And initial results of Simo Spine show that probably the soft tissues, residual stresses may be like a first early sign of the proximal junction failure. And we have decided to implement a spin-off like Simo Spine as a medical device software to like a tool to predict the proximal junction failure. So the problem was that how could we like implement the suboptimal correction spine surgeries, and how can we decrease or mitigate the risk of mechanical failure, and how can we develop a suboptimal spine surgery planning. And the solution was that, okay, using some mechanical tools and numerical simulation like finite element simulations, we were able to, like using a tool to predict this kind of mechanical complication. And the challenging was that how can we personalize the models of the thoracolumbar spine to be adapted for the final element simulations. So regarding these problems, challenging, I had my PhD thesis working especially on proximal junction failure stratification in adult spine surgery using 3D patient-specific final element models. I defended in 2023 with supervision of Jerome and Miguel. And also, in parallel, we had another PhD thesis of Alex Delarco, like clinical PhD thesis, also working predicting the proximal junction failure complication in adult spine deformity. And this is a technology pipeline of SIMO spine. Generally, in SIMO spine, we need just annotations, clinical annotation of the spine, like using the spinopelvic parameters. We need just these parameters using some clinical routine softwares like SurgiMap. The orthopedic surgeon can measure these parameters, and then using a statistical shape modeling integrated by mesh morphing techniques, we were able to develop a tool to generate any patient-personalized thoracolumbar spine models. And then we prepared models for FEM simulation, final element simulations. And the case control study showed that we are able to discriminate the failure and control cases, and we were able to analyze and exploit the risk index parameters of spine surgeries. So this is a tool that I developed, integrating a statistical shape modeling and mesh morphing techniques. In this tool, we are able to generate any deformity in a spine. And also, we were able to sample 16,807 models, and as you can see here, and all of these models, we measure all the spinopelvic parameters. And for example, this is a model that, one sample model that you can see here in final element in Abacus. And then regarding all this data, we were able to publish something in scientific data for like a cohort of the data that we sampled, 16,807 models, patient personalized model, and also the models that they use for final element simulations. And also regarding the biomedical risk index, we were able to publish another publication in a spine journal. But honestly, we had a dilemma here for like between dissemination and a spin-off. Having a spin-off, we had a dilemma to choose like to protect the data, because somehow we couldn't publish something because the aim was like creating a company or a spin-off. So the dilemma is like compromising between these two things, and we are still, for example, for the data that I have shared, the data was shared in a public repository, but we have decided to have like some restriction in the data. Not everyone can have access to them, and also we are still working on like protecting the data, having the patenting, and also finding a compromising between creating a company and also the dissemination steps. So the result of SIMO spine showed that using these technologies, modeling and final element simulation, we are able to predict the proximal junction failure with AUC of 0.98. And we could consider the fiber strain as a biomechanical descriptor for stratifying the proximal junction failure. And also we were able to find the threshold for fiber strain. And also we were able to compare the predictability of fiber strain to previous predictors like gap score, and we found that the fiber strain predictability is much higher than the previous the previous predictors like gap score. And the preclinical assessment showed that out of 18 cases, blind cases actually, the 17 cases were predicted well using CMOS spine technology and index. And also using the CMOS spine technology, we're able to like test different scenarios in spine surgery, testing the number of screws, and also different material properties of the bone, and also material properties of the rod. At the end, the CMOS spine technology, as you can see, there's no need for the images of the patients. The only need is the spinopelvic parameters of the spine. And then by activating the shape modes in statistical shape modeling, we are able to generate any deformity. And then using CMOS spine technology, we are able to test different configuration and or topology of the surgery planning. And as you can see here, in this figure, in the bottom, we are able to see the risk indexes of spine surgery. And the green ones are low risk, and the red ones are high risk. And also, we could see that if the surgeons will have, like, for example, if the patient have the osteoporotic conditions, and also the rod, for example, is chrome cobalt, the surgery will be high risk. But if the patient has like a healthy bone and the rod is titanium, we can consider it as a low risk. We could have this kind of color mapping and introducing them to the orthopedic surgeons to know and to predict the risk of spine surgery. So these are the team in CMOS spine, me as a technology developer of the CMOS spine, and Pablo here as a technology transfer part of CMOS spine, Alex Delarco, Jerome, and Miguel Angel. And at the moment, we are working on V&V conditions, V&V verification and validation for CMOS spine. We had some analysis like validation for range of motion, monosegmental, multisegmental range of motion validation for thoracolumbar spine. And also we had some preclinical validation, but we are still working in this part. So this was just a technology that I presented to you, but the thing is that we wanted, the aim was transferring the technology to the clinics. So the next part that Pablo will present is just for transferring the technology to clinics. Yeah.
Do you know where the files are?
In the
Here, no, Pablo. Do you want to say? Okay, good morning, everyone. My name is Pablo, and as Morteza presented me, I'm trying to develop the part of the technology transfer, thanks to also Nuria here in the Department of Innovation Unit in UPF. And I'm going to talk a little bit more about the business and the regulatory and the IPR part. So it all started at the end of 2022. I had like some interest in biomechanics after the degree, and also had some curiosity about the technology transfer and entrepreneurship after taking a subject called like this. Then I knocked on Jerome's door to ask him for a bachelor thesis, asking him like about that, about biomechanics, of course, and something related to technology transfer. So Morteza was finishing his PhD with nice results. So I started the bachelor thesis on January 2023 with Morteza and Nuria as co-supervisors with Jerome. And I started to get trained because I didn't know a lot about tech transfer, innovation, and all that. So I decided to enroll in a course called Technology Entrepreneurship from Lab to Market online. And also we got accepted in the pre-acceleration program for Barcelona Activa, which was very useful, even though we were like very early stage to start. And also I was trained with Asphalion, a regulatory consulting firm, in software as a medical device regulation. And now we're taking the SharTech Salute, which is a network of health tech related and biotech spin-offs, Venture Builder. And also we got a grant called Javor that goes along formation programs too. So as we all know, life expectancy is always growing, and sedentarism too. So there is a lot more of spine surgeries and complications. As Morteza said, of the total spine surgeries performed every year, 45% fail, and 25% of these failures are due to mechanical complications. So it's very, very important to tackle the problem. It's a healthcare burden because it causes a lot of pain, disability on patients, and risk of fall. So they can break some hips or even their femur and cause the death. They often need caretakers, and the revision surgeries they perform on them are very aggressive as they are fragile people. On the economic side, these revision surgeries are expensive, depending on the country, but it's like 50,000 euros, counting implants, doctors, and all the related parts. Also, there are a lot of implants waste, complementary imaging to follow up, and hospitalization costs. This part was explained by Morteza, but very quick. The normal common failure is proximal junctional failure that occurs on the upper instrumented vertebra here. As you see, there's some screws and bars that can be titanium or chrome cobalt. And the early sign is normally affecting the soft tissues like the IVDs, and that's why Morteza worked on the development of this prediction tool. Well, this was explained by Morteza, so I will skip it quick. And also the assessment we did to of the capacity to discriminate mechanical failure. But it's important to highlight that there was a 94% of success in the first 18 blind cases tested in the Hospital del Mar. So I'm going to talk now about customer discovery part that Sergio was talking about. It's a very important part. So I highlighted the first customers. So we are trying to reach key opinion leaders and also implant manufacturers, as we think we have like a nice tool to test their implants. And our main partners and supports and collaborators are Hospital del Mar, Hospital Vall d'Hebron, SharTech Salute, Agaur, and 3D Shaper, a company working in the X-ray images to predict osteoporosis in bones. About the interviews we did, as far as now, we had like 3 important interviews with KOLs, and the key findings were that they are aware and support reliable and user-friendly technologies and tools, but they request some usability and easy to use, so they don't want to learn anything new more than their common practice. They're also more aware about the biomechanical biomarkers and low distribution importance, and they're willing to improve their own performance. As you saw, there are a lot of revision surgeries, and they want to be the first one to try to avoid them. And we have to look for the early adopters, so the ones who are more keen on adopting this technology. The common clinical workflow they follow is just a personal interview about their pain and how they live their lives, their lifestyle. Also, they do some physical exploration, like they do some manipulation and movement techniques in order to see how they move and how they like their quality of life. And also they perform some complementary imaging, normally X-ray imaging, and then if they want to explore some like soft tissues, and if they want to, like, for example, do like spinal cord assessment and all that, they perform MRIs and CT too. So their major pains are high number of aggressive revision surgeries, and that their execution does not resemble the planned surgery. So we need to find like a correct product market fit. Also, we had some meetings with some big implant manufacturers like Stryker and Johnson & Johnson, which is now joining forces with Depuy Synthes. And of our surprise, they had some interest to follow up. And also last week, Morteza received a mail from ATake Spine from US, which I didn't know about them, but they're very interested in the data set he published in Nature. Also, our value proposition for hospitals is a fast and better informed planification and reduced reintervention. So about like using our mechanical risk indexes that incorporates bone quality, weight of the patient, also the screws per level in each vertebra and all, and the gap score. And also, we have to find a way to fit into their common experiential workflow and provide security, save costs, and time. And for the implant manufacturers, it's just a way of testing their implants using virtual cohorts, so they can test fastly and with less costs. About the market, it's a big market, growing 5% every year, and the major players, as I said before, there are Stryker, Zimmer Biomet, Medtronic, Johnson & Johnson, among others. The largest market is the US, and the fastest growing is Asia Pacific. As you may know, they have a big population. So I calculated the total available market and serviceable available market, which are important for investors, but it's just a sketch. So I took into account the population, the total population in Europe and the US, and knowing that between 30 and 68% of the adult population will suffer adult spine surgeries, I made some calculations. Also, I approximated the surgery cost of 30,000 euros. So I took the lower extreme of the percentage here. So it's like 47 million people will suffer ASD. More or less 20% of those are like very challenging, so will undergo surgery. The revision surgery is about 45% of the cases and 25% of mechanical failure, so 1 million people. So that's the estimates of the TAMs and some values. So about the competition, we have like 4 main competitors. I forgot to put one because they're not in the market yet. Only Medtronic is on the market with their AI software based. But we have Mechanical Finder, and we also had some meeting with them last year, and we found out that they are research based, so they just perform simple simulations, and they're commercialized for research objectives. Twins and Medical is a French company, also focusing on computer modeling and simulation, but they're focusing more on the knee, even though they're working on the spine too. And Medtronic is an AI-based software that uses data from old performed surgeries and tries to guide the planification of the new ones. And also MedSim, which is a company was founded last year in Luxembourg, and they're working on the same, but as I told you, they're not on the market yet, so they're difficult to analyze. Our business model will be a business-to-business, software as a service, based on a yearly subscription. This is just a sketch, but I think it will be the most suitable part. We will count with a basic license and a potential premium license we're working on. The user profile, as I told you, is hospitals and spine surgery and implant manufacturers, even though we could target 2 more, which will be the training centers for surgeons and also medical imaging companies as an add-on, and the pricing strategy need to be determined. About the marketing part in the future, even though it's important also in the present, we are reaching key opinion leaders, and we need to go to some congresses and events in order to get to know important people. Also, we need to set up the webpage in a user-friendly form and try to focus on inbound marketing using SEO strategies, and also use some social media in order to capture some potential clients or partners. About the roadmap, it's the important part, and the main important part is to finish the MVP by early 2025, and also focus on usability engineering, as it's an important part of the regulatory process. About the IPR, we've been doing a preliminary patentability study internal with the help of Nuria Brunet and the innovation unit, and we are trying to run the patentability study during Q3 of 2024, and hopefully fill the patent during 2025, the first or second quarter, and try to then extend to the patent cooperation treaty in order to cover the most important innovative countries. And then the regulatory, which is, I'll pass to the next slide because it's more complete. So the regulatory part was subcontracted using money from a grant called Chartech Valorization Call, and it was run by Viromi. So we defined our intended purpose and our device description more or less, even though it has to be refined, and also the device classification. Of course, we have to focus on covering the general safety and performance requirements stated in the regulatory, and now we're actually working, as Morteza said, on the verification and validation plan, which was created in America by the American Association of Mechanical Engineers, and we're using the BMV40, which is focusing on medical devices, and BMV10 for solid mechanics, and also focusing a bit on usability engineering, as we are working also with a student from UPF called Victoria Ives, which is doing her practicum or internship with us, trying to define the front end of will be the potential software. The first speaker said, it's important to also take into account the QMS using ISO 14385. Also, the risk is very important in medical devices, ISO 14471, and finally, take the importance of the maintenance of the life cycle of the software using the IC 62304. And finally, hopefully get the CE mark. About the device classification, the risk can be assessed using these two factors. So the state of the patient condition. So in our case, it's 65-year-olds and older. So they're very, very fragile, and they suffer a lot of pain, and they, like a surgery is very aggressive, so we decided it's a critical situation, but we don't try to drive clinical management or treat, like the last decision is made by doctors. So it would be a law to inform clinical management, so it would be a class 2A and category 2.1. About the team was introduced by Morteza, and you all may know all of them, so I'll skip this slide. And finally, about the economical viability, we expect like some expensive in IP, like 25,000 euros. The regulatory was assessed by, as I said, by VIDAA, a company from Valencia, I think, and it was stated that it would be more or less 350K. And during the next couple years, we will need the finite element solver license, which is expensive too. It's like a 70K per year, and more other resources which will need to be calculated, like human resources or cloud services. So we have raised some public funding, 75K for the moment, but we are targeting also Agaur Producta, which is the next step of Jabor, Caixa Impulse, and Innovalora, and try to found the company someday, hopefully, and try to get like some public funding directed to this kind of companies, early stage, Neotech, Startup Capital, and NISA, and hopefully someday we will get to the early stage seed rounds in private, like venture capitals or business angels, and finally get going. And thank you for listening.
Okay, thank you. We've blown up a little bit the timings. Jordi, don't worry, we have comfortable time for discussion, so no pressure. Just do your talk as. Okay.
A veure... El rebré, jo veig. Yes. Vale. Sí, sí. Vale. Ups. No sé per què fa aquest soroll.
Ah, és perquè hi ha un zoom amb la...
El meu. veure si això es veu ara. Si no... Ah, vale, ja està. Bueno,
Okay, so we've screwed up everything.
tio, com pot ser? És que és raro, tio.
Reactivat.
Doblar pantalla or something like this, you press it
Where?
in Zoom.
No, but it's not Zoom.
No zoom.
Do you have a Jose?
Que raro, tio. Sí. Sí, és raro. Ui, perdó.
Okay, so we'll start basically. So Sergio, if you want them to come in front. So we'll start with then Sergio, Pablo, and Morteza, and then so we'll continue with Jordi once Jordi will have presented. So first of all, thanks. So I have a first question, and maybe this is a bit more for Sergio, but then Pablo and Morteza also then can give their opinion. is, so when you have presented, it seems that the motivation has rather been technology driven than clinical need driven. So can you comment on that? And if so, basically how it has impacted then this, I would say, first wrong step, and then the need that you had then to pivot again?
Yeah, I will say that it was clinically driven in the sense that we had a project in collaboration with Pakistan, and they needed a platform to do this management and the analysis of their ultrasound images. And also they needed a solution to quality check their images and have a training tool for the field staff to train with this feedback given by other senior clinicians to improve their imaging. So in a sense, that was a clinical motivation that led us to develop the technology throughout our research project. And then we thought, okay, so probably part of this technology may have an impact in the market. But the reality, and as I explained, is that probably the way we were framing it, sometimes we were very overly optimistic. And the ideas and the thing is that the features that we wanted to market, probably, or the way we were doing it, or yeah, it's probably the way we were selling, it doesn't have a competitive advantage. So now what we are doing is going a step behind and see how we can, again, in the end, our technology is developed throughout research. We think sometimes that there is the clinical need. We identify the need. There is a need in a research project. The reality is that when you go out there and you ask 100 clinicians, probably the research need is there, but this doesn't mean that that can be translated to the market as a product or a service. So that was a bit the experience.
So maybe then, so then continuing on this, what is driven by what? So if you would talk about CMO Spine, so what is your impression when you then talk about CMO Spine to stakeholders or to investors, so during the training sessions? Do you have the impression that you can easily defend that you're clinical need driven, or do you have the impression that sometimes you're too technologically driven in terms of motivation?
Okay, so I will start. In my case, I was not there when the problem, well, I was here studying in university, but when the problem was asked by the surgeon, the Alex Del Arco, I guess that there was I know that there was a clinical need because mechanical complications is a reality. So a lot of surgeries fail, and a lot of these experts suffer so they have to repeat a lot of surgeries. But in my case, I did some interviews, and they confirmed that they have these problems, but when you present them like a video or a kind of explanation of the solution, what they want to add is more features and more things that they think they're important. In our case, was the abdominal perimeter, so not only considering the weight, but also how it's distributed along the body. And also they request to model also the muscle forces for the lumbar and for the thoracic part. So there might be like the possibility to pivot and try these things, but they don't try to understand that we're working on the worst case scenario. For example, assuming that there is no force holding that spine. And yeah, they have tested so many softwares like SurgiMap, Keops, and all of them, and they don't seem like to trust one of them. They just are keen on trying, but they don't support these, like, they don't think they can perform better with those yet.
Yeah, so maybe it comes down to the communication with the medical doctor. So in order then to understand, so what is the need, what is the technology, and so make them accept that your technological proposal can address a need, and then the trust is this proposal. So here, for example, Sergio. So beyond than this Pakistani medical doctor, so have you then also iterated then with other medical doctors, maybe in Barcelona ecosystem or elsewhere, to frame a little bit better, to narrow down what TransCore should be at the end?
Yes, we did indeed. Now, actually, at the beginning of this year, we were conducting what we called a qualitative kind of customer discovery. And we had interviews with 6 cardiologists, 3 pediatric cardiologists, and 3 adult cardiologists. It turned out that they have different needs. And mostly what they were suggesting is that rather than making automated analysis out of the images, so provide all the metrics, all the kind of functional measurements of the heart, anatomical measurements, and so on, they already wanted to go a step further and going towards the part of having the support of a tool on their clinical diagnosis. The reality, and for us right now, for that to be a reality in certain pathologies, what you need is a lot of collaboration with different hospitals, have the data and so on. And when you are in that stage, I think you really need to assess what are your competitors, what are they looking at, the different pathologies and so on, and the muscle that they have to collaborate and to get data. And so in a way, we decided probably it's not worth like really pursuing, for example, this going towards heart failure. Probably there are other features in our software that could be more interesting to exploit. And probably this part of, as I said, we have our solution deployed in the cloud, but also in different hospitals. And we are now developing an orchestration, what we call an orchestrator piece, that enables that different hospitals can collaborate with each other without really sharing their data, but only the knowledge that they get from out of it. So we said, okay, probably rather than pursuing this path that clinicians were saying that we could solve this and this disease and provide clinical decision tools, probably we can create technology that tackles a different problem, because we are now partially confirming with a deep market research study that such solution doesn't exist. So in the end, it's a matter of, okay, after talking, after looking what are the needs, what is in the market, probably try to find a way to identify niches in that market that are not covered, and then tackle that rather than something that everybody's doing.
Right, so if I, yeah, we would just close that part of discussion, and then, so Jordi, you're on the floor.
I think it's quite interesting because I have a different vision. Actually, I think that what it drives is market and the money, actually. And I think that it can be seen with VIDAA, for instance, that it's so that in our case it was a little bit different, because from the beginning we have a physician, and it was the physician who guided us to the clinical need. But then, as I tried to explain in the presentation, that I don't know if I will be able to do it properly, but the thing is that we change. So we were super focused on simulations. And the reason that we did a platform that do all the process, it was not the physician, it was not like ourselves because we are very smart. It was Abbott, for instance, that say, hey, look, I'm not gonna pay 2 softwares, one to do simulations and one to do medical images. And at the end, the physicians can be on board with you, but the guy that is paying, and Pablo has showed in his business plan, is the medical device companies, or at least the hospitals. And both of them, our hospital is like a company. It's based on money. It's like how you can save us money with this platform, you know what I mean? So at the end, I think that market place yourself where you deserve to be. I mean, your technology can be super cool, of course, or in the Sergio's ones and, but well, yours, Spine, it's super cool. But at the end, what will determine if it's success or not is a lot of factors that don't depend on you. But I think it's my point of view. Rather than do a lot of iteration with physicians, that you have like, and I have an example here, a lot of different opinions, and at the end they are not paying. You know what I mean? So it's like, we did a lot of surveys with a lot of different feedback, very useful feedback, I would say, to achieve like a very technological, mature point. But it's like, okay, at the end you're gonna pay for this.
So I think that's nice, and I think it's not really too different or too incompatible with what has been said. Maybe if I can just sum up in very, very short, as it's super important to do this stakeholder analysis, then to define your minimum viable product, which at the end people will pay, and then be flexible in developing this minimum viable product and not be obsessed by a specific technological target. Now, would you agree with that? Yeah. Anyone would like to ask questions? Would like them to raise an opinion about this? Maybe Nuria, before we jump to Jordi's. Okay, let's do that. So, Jordi.
The presentation. So I know that it would be like a pitch, but I know that the audience here is, you are not to put money. I mean, if you are very rich and you want to put money, feel free to contact me. But at the end, I had the feeling that all of you are students, right? And as you will see with VIDAA, part of the team or great part of the team, we are students, or researchers. At the end, what you want is like, okay, what I do, I would like to have an impact further, no? And I think that VIDAA can be a very good example. This was a very moment for us, very nice moment for us. It was almost half a year ago. It's not, I mean, it's not the end of it. I would say that it's not also where it started. It's just a very nice point that we can see that, okay, we can have an impact. But again, it's like we are not getting money yet, so there is a long way to go there. But before that, you need to understand what is VIDAA, and VIDAA is just a tool to help atrial fibrillation patients. Very quick, atrial fibrillation is just an arrhythmia that makes that your heart cannot beat properly. And this can generate clots inside the left atrial appendage. That is this cavity that you can see here. And of course, then they can travel to the brain and generate an stroke, right? So the thing is, okay, what happens with those kind of patients? So until some years ago, you have to give them a pill for life every day. The problem here is that a great part of them cannot take those pills, so they are untreated until some years ago that you have this intervention that you plug the device, the left atrial appendage, that is the source of thrombi, right? So the idea is perfect. It's very nice. It has to fit. And that's a problem, that it's not very easy to do this intervention because it's not open chest surgery anymore. So there are challenges because depending on how you place the device and the device that you put in anatomy that changes a lot among you. I'm sure that all of you have different left atrial appendage. So you have or you can have device-related thrombus, leaks, embolization, so very serious problems. So, okay, with all of that, how it started? So it started with long time ago. You cannot see here, but it's 2016 with Andy and Oscar that are starting to use simulations, only simulations, how we can predict blood ecstasis in left atrial appendage with simulations. And it was 2016. Then in 2018, Ainhoa and myself, Ainhoa as an undergraduate, myself as a master student, started to work on this. And then here you can see the first VIDAA, I'm not going to say MVP, I'm going to say the first draft. And it's very curious because it's just Ainhoa as an undergraduate, TFG, she did a platform where you can get, a first left atrium and put some devices, but nothing more. And then myself, I ran simulations. But it's very nice because at that moment, Andy was years ahead and was saying, okay, let's do a startup of this. We can do this. And honestly, Ainhoa and Oscar will say, so. And it was me who said no. And it's because I don't know if it's like because I wasn't a student, I have like the imposter syndrome. It's okay, my simulations are not good enough. There are a lot of things that needs to be improved. It's not behaving like a heart. I mean, the threat of Bart saying that it's bullshit and all this stuff. And I said, no, I mean, we are not ready to get this. And you will see now in the few moments that I think that this was the first mistake, a mistake that I've done. But the other thing that is very important, as I was saying, I think that from the beginning, the clinical need was guided by the physician that is part of the team. I was like visiting him, having one meeting first year as a PhD student with Xavier Freixa, showing all the colors and arrows that you learn to do in MOS. And the thing here is that he told me he believed in the simulations. He thought that it was very interesting. But then he asked me, OK, how much time do you need to perform a simulation when I give you a patient? And I said 1 week, being very optimistic because I wanted to do a full FCI. But even with that, he told me, OK, then come back when you have something useful. Because since I get the patient, I decide to operate them. I have only 2 days, so I need something with 2 days. And this drive, not only the business, I mean, it's not business yet, it's just my PhD. I had to do something with, I mean, in 48 hours, but just to have a clinical impact, nothing related to business. And as I said, this is very difficult, because from a technical point of view, we try like to be like very, engineers, and this is very difficult. But we get it. We do like a first workflow, and the simulations had limitations for sure, but I was blinded, and we were able to predict the DRT in 6 patients. So that's where everything started. And then we are very lucky, because as I said, academic yoga strikes again, and that's you. Carlos joined the team, and I think that he brought the simulations to another level, continuing the work. And we started 2 things. The validation and verification work that Pablo mentioned also, that tried to give credit to our simulations. But then, at that moment, physicians started to ask for cases. So we realized that we couldn't handle this anymore as an academy. We didn't have time. And at the end, we decided that, OK, maybe we have to study if we want to do like a spin-off. That's why Andy was right. But as I said, people think very differently. And as here is the example that I said. Paul Peterson, that is the global marketing of Abbott, say, OK, that's very nice, but I'm not going to pay two softwares for one planification of one intervention. Then I have people that found very useful, like the anatomical part and the medical image part, and people that say that simulations is very useful. No? So this was driving, OK, we are not going to do simulations anymore. We do all the pipeline. So when patient enters, we do all the analysis, anatomical analysis. We use artificial intelligence and another algorithms to determine which device will adapt better to the anatomy of the patient, and then we run simulations. And this worked very well, to be honest. So we submit all this, because again, it's not only simulations anymore. We submit all this as the submission of the patent, and we do our live case. But from that, there are a lot of work to do, because it's true that we got a lot of good feedback, but then you have to do a lot of work. And this path that it seems so short, for me, it has been too long. A lot of work. As you can see here, it's a very long path, but still there are a lot of things to do. And you can see this is only regulation that also Pablo presented. For me, yours is super cheap. I understand that the budget that I got is $500,000, and we are already delayed on the schedule, as you can see here, because there is a lot of paperwork and that is not related in research anymore. Also, you have to do the clinical trials. We are starting with a retrospective one that is almost 400 with hospitals around Europe. And you have to do business plans. The first business plans will be shit. The first business plan I presented, the numbers didn't hold up. No? And this is an iterative process that it takes time to get like the proper things that how to be done. The same with the patent. Do a submission of the patent, it's very easy. Like all the process then, it's very expensive, and it takes a lot of time. And that's a problem, because you are burning money during this period of time, and a lot of money. And also you have the competition that is trying to do the same as you. So it's very difficult to survive this period of time that it can perfectly be like 2 years. Because as you can see here, in all this time, we already burned to 1 million euros. So it's a lot of time and a lot of money invested. But we are a very good team, I think. We are a big team actually now, but I think that we can make it. And this is a little bit the situation that we are now. And lessons I learned, and I finish with that. Manage frustration, for me it's very difficult. It's like when I do pitches with investors or whatever, it's very difficult. It's very different to do a pitch here or, you know, or explain your research, nothing to do with it. And it's impossible to be done. Being one, you need a lot of people that know a lot about business, a lot of tech transfer like Nuria or another colleagues. It's impossible to do it alone. For me, it's all about money. It's what I learned. I mean, your technology can be very good, but it's all about money. It's what drives everything. And this is Andy's statement that it's very important to start. And we were discussing that. For me, it's more important to have a minimal MVP and start having feedback from different stakeholders than the mistake that I made myself to say, no, I want like a super cool simulations. I want to be perfect. And I think that that's a mistake. So that's all. Thank you very much. I'm sorry if I go very quick. But yeah, I wanted.